So guys, let's continue from question 21 onwards of the same examination, which is 2018 winter variant 1. Insoluble salts are prepared by reacting aqueous solutions of soluble salts, which is something we know as the precipitation method. A precipitate forms. Which pair of aqueous solutions form a precipitate? Barium chloride and nitric acid. So when barium chloride reacts with nitric acid, it gives you rather barium nitrate, which is BaNO3 twice. And then the H part, the proton of the nitric acid, reacts with chloride, so it gives you HCl. So not a precipitate. 1 is wrong. Barium chloride and sulfuric acid. Barium chloride has barium ions over here. Sulfuric acid has sulfate ions over here. They make barium sulfate precipitates. Barium nitrate and nitric acid, again, okay, that is barium nitrate and nitric acid, shouldn't give you that, because again that's going to be barium nitrate over here. You're not going to get anything substantial as a precipitate. Barium nitrate and sulfuric acid. So again, barium is here, sulfuric acid is going to give you barium sulfate. So 2 and 4 are the only ones which give you precipitates. The diagram shows the main stages in the manufacture of an ammonia-based fertilizer. Nitrogen and hydrogen are reacting in the presence of iron, and it's going to give you ammonia. Once separated, ammonia can be used to make fertilizer. What is happening in the process labeled X? Ammonia is returned to the start of the process to shift the equilibrium towards the product. That is not true. Why would you use ammonia to be sent into the main container again? Even if you sent ammonia in the main container, the equation goes something like this. Even if you sent ammonia backwards into the main container, it will shift the equilibrium towards the left side, not towards the right. So that is wrong. The gases are cooled to cause ammonia to form a liquid. Okay, but making it liquid does not have anything to do with sending it back to the original container. Unreacted hydrogen is recycled. Unreacted nitrogen and hydrogen are recycled. So you're recycling the gases, you're sending them back to the original container. What is the use of sulfuric acid? Is it a bleach? No. SO2 is a bleach. As a food preservative? No. Again, SO2 is a food preservative. In the manufacture of detergents, in the manufacture of vanadium oxide? No. Vanadium oxide is a catalyst which is used to make SO3. Yes, it is used in the manufacture of detergents. Which property shows an increasing trend in the elements from group 1 to 7 across a period of the periodic table? So from group 1 towards 7, they are able to make anions because they gain electrons. Group 1 loses electron, but when we talk about group 7, it gains electrons. So their ability to make anions is increasing. Metallic character decreases because group 1 is metallic, group 7 is non-metallic. Number of electron shells remains same because they are a part of the same period, remains same. Reactivity with water? No, sorry. Group 1 reacts with water. Group 7 does not react violently with water. So that is also wrong. So A for apple is the answer. The melting point of lithium is 181 degrees Celsius. The melting point of sodium is 98. Which statement explains why lithium has a higher melting point? Lithium and sodium are both metals, so it should be something to do with metallic lattice. Lithium has more valency electrons than sodium. No, that's not true, because they have the same valence electrons. They're in the same group of periodic table. Sodium is more reactive than lithium. That is a chemical property. That's a chemical property. The question is concerned with melting point, which is a physical property. Sodium is softer than lithium, maybe related to the melting point. The attraction between the positive ions and the sea of electrons is stronger in lithium than sodium. Yes, that is exactly related to the metallic lattice, which makes this option very sound. From their position in the periodic table, which properties would you expect the elements vanadium, chromium, and cobalt to have? Variable oxidation states? Yes, they are transition elements. Colored compounds? Yes. High melting points? Yes, because these are the properties of transition elements. Question 27 says, which statement about alloys is correct? Alloys can only be formed by mixing copper or iron with other metals. No. There can be other metals over here. High carbon steel alloys are soft and easily shaped. No. If they have high carbon, they are very hard and they are, sometimes stainless. In an alloy, there is attraction between positive ions and sea of electrons. Yes, that is true, because they are a mixture of metals and they have their own metallic lattice. Even if it's not a lattice, they have this metallic nature, which means positive ions and sea of electrons. The alloy brass has a chemical formula. They don't have a chemical formula. They are mixtures. They are not compounds. Not compounds. Question 28 says, the list shows the position of metal X in the reactivity series of metals. Which statement could be used to extract metal X? Since it's below iron, it's definitely below carbon. So electrolysis of solid metal oxide, solids can't be electrolyzed. Heating the metal oxide with carbon, since the metal X is lower than carbon, carbon cannot, since it's below since it's below iron, it means it's below carbon, so carbon is gonna displace it. I should say carbon can displace it. That is true, because carbon is gonna displace it. So since it is lower than carbon, carbon can displace it. Like for example, carbon if reacts with X oxide, X would be separated and carbon is gonna make carbon dioxide. We can do the balancing later. Heating the metal oxide with copper, no sorry, because copper is lower. Since copper is lower than metal X, copper will not displace metal X. So only statement 2 makes sense, which is option C. Question 29 says, an old commercial process for aluminium extraction used large quantities of sodium to convert aluminium ions into aluminium atoms. The modern aluminium extraction process uses electrolysis. Which statements are correct? In the old process, sodium acted as an oxidizing agent, which means that sodium would reduce itself. I think it's wrong, but we'll see how. The reaction worked because sodium is more reactive than aluminium, which is true. Yes, sodium is more reactive. They are saying that sodium reacted with aluminium ions to make aluminium atoms, and obviously sodium made its ions. The balancing equation should look something like this. Sodium is not behaving as an oxidizing agent, rather sodium is the reducing agent, because sodium is oxidized itself. You can see sodium is oxidized itself. So sodium is a reducing agent, not an oxidizing agent. In the modern process, the equation for the cathode reaction is aluminium ions gain electron and make aluminium. That is true, because at cathode reduction happens. The carbon anode needs replacing often because it is oxidized to carbon dioxide by the oxygen. That happens at the anode, which is true, that happens at the anode. So let's see. In the old process, only statement number 1 is correct. Only statement number 2 is correct. But in the modern process, statement 3 and 4 are both correct. So D for doctor is the right answer over here. Which element is always present in steel? So steel is mainly an alloy of iron, so definitely iron. Carbon could have been a very good option, but carbon is not even here. Aluminium is used to make saucepans because of its apparent lack of reactivity. Which property of aluminium explains its unreactivity? It has a layer of oxide on its surface. That is very true. It has low density. Yeah, but that is not related to lack of reactivity. It is a good conductor of electricity. Yeah, but again, not connected to the idea of lack of reactivity. It is in group 3 of the periodic table. Again, true statement, but does not define lack of reactivity. It makes a layer of aluminium oxide, which covers its surface. Question 32 says, pollutant gases are released by the bacterial decay of vegetable matter, which is actually methane. This gas is actually methane. The bacterial decay of vegetable matter is the main source of which gas? So obviously it has to be methane. Methane is released by the decay of vegetable matter. Lakes contain a variety of dissolved substances. Which substance is responsible for eutrophication? So it has to be the ions. It has to be nitrate fertilizers because they're released by the farms, and they're going to help in the eutrophication, the algal bloom, the growth of algae. How many of the molecules shown below belong to the homologous series of alkanes? Alkanes means CnH2n plus 2. So this is the alkane journal formula. C2H4 is not alkane, it's ethene. C3H8 is alkane. C4H10 is alkane. C5H10 is not alkane, it's actually pentene, it's an alkene. And then C6H14 is another alkane. So there are 3 alkanes over here. The diagram shows the structural formula of an organic compound. Which statement about this compound is correct? It is a saturated hydrocarbon. That is true, because you can see only carbon-carbon single bonds. It is an alkene. No, sorry, it has no carbon-carbon double bond. It is an isomer of butane. Butane has a formula of C4H10. I can see 4 carbons, but I don't see 10 hydrogens. So there are no 10 hydrogens. It will undergo addition with hydrogen. Addition is only for alkenes. Since it's not an alkene, it is not D. So A is the right answer. Question 36 says, which statement about vegetable oil and the margarine made from it is correct? Both are liquids at room temperature. Maybe, maybe not. Both occur naturally. No, margarine is made by the human process. Margarine has a higher melting point. That is true, because alkanes have higher melting point than the same number of carbon alkenes. So margarine has always a higher melting point. Vegetable oil has fewer carbon-carbon double bonds than margarine. No, true. It's not true. Vegetable oil has more carbon-carbon double bond. And then vegetable oil reacts with hydrogen to break the carbon-carbon double bond to make margarine. Which group is found in alcohols? So the OH group is found in the alcohol, known as the hydroxyl functional group. An ester is formed from a carboxylic acid and an alcohol. How does the number of carbon, hydrogen and oxygen atoms in an ester differ from the total number of these atoms in the carboxylic acid and the alcohol from which the ester is formed? You can see that to make an ester from an alcohol and an acid, you remove H and OH. So hydrogen are less, oxygen are less because they are gone to make water, but the carbons remain the same because carbons become a part of the ester. The carbons become a part of the ester. So carbons remain the same, hydrogens are fewer, oxygen are fewer because they are lost to make water. Which statement about the composition of polymers is correct? Nylon contains oxygen atoms but not nitrogen atoms. Not true. Nylon has oxygen and both nitrogen. Protein contains both nitrogen atoms and oxygen atoms. That is very true. Pterylene contains nitrogen atoms. No. Pterylene is a polyester, not polyamide. The polymer used to make cling film contains oxygen atoms. That is actually not true. It's a kind of an addition polymer. So again, it's not true. The answer has to be protein contain both nitrogen atoms and oxygen atoms. The last question says polystyrene is an addition polymer. The partial structure of polystyrene is shown. What is the formula of the monomer from which polystyrene is made? You can see this is your monomer. Over here you can see your monomer being highlighted. These 2 carbon atoms are the central, so they should have a double bond between them, and then H on the left side, C6H5 and another H on the right side. So B for Barrows is the right answer. In the next video, we're gonna be doing some other paper. Stay tuned, guys. Thanks.